All right, some questions. So Aaron, this is your homework, and for 9.35, you got it right. It's just that you counted wrong, so I just want to point it out, okay? So if you go from a number to another number, and you want to know the number of numbers, what do you do? How do you know how many numbers are there between 82 and
So subtract 82 and add 1.
yeah. So if you subtract 82 from 9,999 and add 1, what do you find?
Um,
Mhm.
so 999 minus 82 is 9917. So it's 9918.
Yeah. So 9918 for you, this one, okay? Yeah. So somehow this one you just got a wrong answer here. And then Reika and Lily, you guys counted 10,000 in, right? Remember? So yeah. Okay, so this question and nothing more. Okay, so we do some questions together because for challenge problems, some questions we don't have
Oh, I have a question on the review.
yeah,
I think it's 9.32.
9.32. Okay.
Yeah. Um, why do we have to find the point on the intersection point?
On the intersection point. Okay. So we explained
Not
that
bounded by three regions though.
what's that?
It's not bounded by three inequalities. So how do we know?
Mm. Oh, if it is not bounded by three inequalities, then you just draw maybe a rough sketch, and then you will see that the intersection works. So, for example, if you draw a rough sketch here, I'm gonna draw it really quick. Um, the first one, let me see. This is 32. This is first one is it's roughly like this, and second one is roughly like this, right? Okay, so something like this, right? And the solutions are this part. Okay. Now when you have something like this, you're gonna first ask yourself, so you're given you're gonna find the value of x plus y, right? So here it seems like there's a maximum value of it. And recall that when you have this kind of problem, the maximum possible value or minimum possible value for this
Right, that's the
will be
point.
at the intersection.
Yeah.
Yeah. In this case, maybe I mean, for any similar problems, you just need to find the intersection and test it out. Because if there exists any maximum or minimum possible value, it will be at the intersection. Okay. And then secondly, we know that there is a maximum value. If you want, you can draw x plus y equals k. Okay, x plus y equals k. If you want to know how to draw it, maybe you can start with 0 and then you go 1, you go 2, you go 3, and we'll see that the line looks like something like this. This is x plus y equals 0. If it equals 1, you will move up a little bit. So something like this, you will move up. If it equals 2, it moves up. If it equals 3, it moves up. Something like this, okay? And then you will know that the maximum value occurs at the intersection. Okay, maybe let's choose decimals. Have a look. So 3x plus 2y. Okay, 3x plus 2y, 7. Okay, something like this. Another one is 2x plus 4y, 2x plus 4y. Oops, plus 4y less than or equal to 8, something like this, right? This is intersection, and the solutions are everything overlapped. on the bottom left corner, okay? And then you can draw x plus y equals k, so equals k. So on decimals, you can add a slider, you see? So when x plus y equals 1, you see where the green line is? When k goes down, you see, x plus y equals to negative numbers, it moves down, and then when k moves up, the green line moves up, okay? And green line is x plus y is the value of x plus y. So you will see that at the intersection here, right? It will have the maximum possible value here. Doesn't really show it, but you know, you can see it. You can see that, right? So when you are graphing this, you can graph the inequalities, that's for sure, right? And after you graph the inequalities, there were some different ways to tell. First of all, always remember, and also Lily and Rika, always remember that when you have some restrictions, if there exists any maximum or minimum value of any expression, it will be at the intersection, right? If there is any. Now, there might not exist any. For example, if I change it to x minus y, there is not a maximum value for it. Oh, sorry, minimum value for it. Okay, sorry, my bad. I meant that if I want to find out the minimum value of x plus y, there's none, right? Because you can always move down, down, down. You see, k equals to negative 10. You can always move down, and you can move it, move the whole line down forever. There's no minimum value. The minimum value will be negative infinity. Okay, so to understand if there is any to know if the maximum or the minimum, if they exist at all, you can either construct this kind of graph, and to graph x plus y equals to k, or any x plus any y equals k, you can just try, you know, equals 0 and then equals 1 and equals 2 and then equals 3 and see how it moves. But it takes a long time, right? So I think the easiest way to do this kind of question is just to try some extreme values. For example, here, this question, after you graph the inequalities, you will know that this part is the solution, right? You know this for the solution. So for example, if it asks about x plus y, the minimum value, then you can obviously see that there isn't any. For example, if you take this value, this is negative 30, right? The minimum value would be negative 60, and then it's obvious that for x you can take as negative as you want, and also for y you can take as negative as you want, right? So both can be as negative as you want, then obviously there's no minimum value. Okay, make sense? And for maximum value, well, I mean, to find out maximum value, you want to maximize x and y at the same time, right? You want to make x positive, you want to make y positive at the same time. So you will see that the intersection is 1. Okay, so as a practice, let's say we have the same two inequalities. What if we do, say, x minus y? First, we find out a maximum value of x minus y, see if there's any. Now, to think about this, to maximize x minus y, you want to first have some positive x's or some big x, right? And also you want to minimize y. So you will see that there isn't any, because for y, you can make it as negative as you want. You see? Okay, so so y can be very, very small. In this case, making minus y very, very big. And meanwhile, see that if you take a very negative y, it actually corresponds to some positive x, right? So when y becomes more and more negative, x becomes more and more positive, then that means for x minus y, there is no maximum value. Does that make sense? Okay, regulated, does that make sense? You graph the inequalities and looking at the region, and you can ask yourself, how do we achieve the maximum value of x minus y, right? X gets bigger, y gets smaller. And you will see that on this graph, it's obviously that it can become infinity. Okay? So there isn't any, so it does not even exist, then nothing you can do here. Okay? And what about the minimum value of x minus y? See if you have any idea for the minimum value.
When it passes the origin.
The origin. Okay, so Aaron, if the minimum value exists, it will be at the intersection. Okay, the intersection will always be the maximum or the minimum value if they exist. Now, if they don't exist, then there's nothing at all, right? So my question is, does the minimum value exist here for x minus y?
No,
No, how do you know?
because it it goes on forever.
Yeah, yeah. So recalculated, does that make sense? There isn't a minimum value either, okay? Because to find a minimum value, you want to minimize x. Now you can see the problem. When you minimize x, x can goes on forever, right? You can make x as negative as you want. And meanwhile, when you are making x negative, y actually becomes more positive. So think about a point in the far left top left corner, right? If you take a point here, x is going to be very negative and y is going to be very positive. In this case, there's no minimum value. You're going to have a negative infinity. Okay, so we do not have maximum or minimum value for x minus y. That's how think about it. Okay, so you don't have to construct, and you don't have to draw x minus y equals k. But if you find this way easier, you can obviously always draw it, or you can always think about it. Okay, so if you think the maximum or the minimum value exists, then it will be at the intersection point. Yeah. For an enclosed area, then most of the time we will have like enclosed area. So if it's a triangle, something like that, then it will definitely have some maximum and minimum values. Okay, so Rika, later, does that make sense? If you have any problem. 瑞克，我不知道这地方你明白了没有？就是他给你一个式子，让你找 maximum 或者 minimum value 呢，我们可以先把这个图的这个 solution 画出来之后啊，然后想一下，看看有没有。像比如说像这个减 y 呢，就比较明显，对吧？两个都没有，对吧？因为第一个你可以把它变得很大很大，然后你要找最小时呢，也可以变得很小很小，也可以变得负无穷啊。But still, let's have a look. What if we have x minus y equals k? You see that's the other way around. Again, if you want to draw this green line, then you can do x minus y equals 0 first, right? And you do x minus y equals, so this is 0. 0. Okay, this is x minus y equals 0. And after you draw this, you do x minus y equals 1, equals 2, equals 3, right? You see at this time, it moves down. It moves up, it moves down, up and down. And there's no way it cannot go, right? Because of its orientation, it's this way. So this part of the line, this bottom left part of the line, we're always going to the shadow part, right? We're always going to this overlap region, which is the solution of the two inequalities. Okay, so there will always be solutions for the green line, no matter what k value is. K can be very large, k can be very small. The green line will always have part of it in the solution of our inequality system, meaning that there's no maximum value and there's no minimum value either. Okay, does that make sense now, Aaron? Good. Okay, any more question? So yeah, if you find this way makes sense, then you can always use this way too. Okay. This way can make sure you understand whether or not the maximum or minimum value exists. And then if they exist, they will be at the intersection point.
So how do you know it's always at an intersection? Why, so how do you know that it won't be on
Okay,
yeah,
so yeah, that was from 2 classes ago. In an example problem, I showed you why that was true. Okay.
what's the right point that satisfied all the inequalities?
Yeah, because the endpoints are always gonna be the most extreme values. So if you think about it, okay, maybe I'm gonna okay. So say that you have any inequalities that form an enclosed region, right? Let's say we have one here. So we have this one, just say this one and this one, just for example, okay? Now say that the solution is here. Now we have 3 endpoints, this, point A, point B, point C, okay? Now the question usually asks you to find out the maximum or minimum value of some linear equations, right? You will always ask you, say, some x, let's say some ax plus by, and you're gonna find out the maximum value of it or minimum value of it, correct? Okay. Now, when we do this kind of question, we graph the inequalities and make this equal to k, remember? Now, ax plus by equals to k. For example, say 2x minus 3y, okay? You're gonna find the maximum or minimum value equals k. That's gonna be a line, correct? And when you change the value of k, the line, and let's say the line is this. Let's say, no, let's say this is the line. This is the line, okay? If this is the line, the blue line, when you change the value of k, it either moves this way or this way, correct? Right? Yeah. So if say that it moves this way, moves down, then only if when it goes through this point B, which is the intersection, will it achieve the most extreme value. If it goes up, then it will achieve the most extreme value either at point A or at point C here. You see, because it's always going to be a line moving up and down, right? It can be this orientation or it can be the other orientation. If the slope is negative, so the slope is negative, it will be a line like this. And again, it moves up, it moves down, right? So the smallest value would probably be here when it goes to C, and the biggest value would be here when it goes to B. Okay, you see that graphically speaking, these endpoints will always provide you with the most extreme value. In other words, if you choose any point that's not at the endpoint, then you can always make it more extreme by moving to the endpoint. Okay, no matter what kind of a line you have. So you have this line L, you can always move it this way more. And at the endpoint, it's going to be, a lesser or a greater value. Does that make sense?
Yeah.
Yeah. Okay, so that's why the maximum or the minimum values, if they do exist, then they will absolutely be one of the intersections. Okay, so that's how we do this kind of problem, right? You just need to figure out what ABC these 3 points are. And to figure out these 3 points, you're just gonna solve the system of linear equations, right? And you can find out the intersections. And after you find the intersections, you plug all 3 intersections into the expression, and the largest among all will be the largest value, smallest among all will be the smallest value. Okay, remember? You make a chart.
An extreme point for two lines, two
Oh,
intersecting
yeah.
qualities.
Yeah, so this is the case for an enclosed region, right? So if it is not enclosed, then it goes back to this discussion. So you first draw it and use some common sense to tell if the value exists, maximum or the minimum value, or you can always graph it, right? In this case, you said this green line, You always have part of it in the enclosed in the solution part. This means that none of them exist, no maximum or no minimum. But if you do say x plus 2y, maybe x plus 6y, something like this, okay, now you see that this green line, it moves down, it moves up, it moves down, it moves up, right? So yeah, this line, no minimum, no maximum, you see? No minimum, no maximum, because again, part of the green line will always be in the overlap region, right? See, part of the green line will always be in this region, in the solution. So no maximum, no minimum. But say that you do this, maybe I'm gonna change the number, say this, see, 3, okay. Now we move it, you see? Part of it, part of it, yeah. Okay, so yeah, you will see that in this case, part of the green line will always be in that region. So no maximum, no minimum. Does that make sense? Part of the green line will always be in the solution, right? So the question is x plus y. But if you do x plus y, you graph it, you will see that, see, at the intersection, this is at the intersection, almost, right? This will give you the maximum value because when you go down, you see, there were a lot of solutions, right? Everything on the green line that's within the solutions and within the overlap region, those will be solutions. But when you make it big, there's only this extreme point, right? The intersection. And after that, no part of the green line is in the solution part, is in the overlap region. In this case, it means that there's no solution. There's no solution, so there's a maximum value, which occurs at the intersection. OK， 瑞卡丽丽，你们看有没有理解这一套在说啥？这是关于这种解方程，大家有没有疑问？如果没有疑问，我们就继续了啊。两条线的话，因为不是个 enclosed region，所以有时候会出现 maximum、minimum value 都不存在的情况。OK 吧？但是有很多方法可以知道啊，除了画图以外，我们刚刚也介绍了，对吧？So Aaron, so other than graphing, you can always tell by common sense. In this case, maximum, minimum, you can always think to maximize x, minimize y, whatever. You will see that because it's an open region, right? Open-ended. That means it's possible to have something to be non-existent. Okay. Yeah. Any other question, Aaron, for review problems? Okay. So regularly, if there's no more problem, let's look at challenge problems. Let's do a few today and then maybe a few more next time. Okay. And then we go to chapter 10. Chapter 10 is much easier and actually much more important. Okay, so this is not a hard one. So describe all x means that you're gonna find a solution. Okay. So first step, obviously we just minus 3. That becomes x squared less than 9. Yeah, so shouldn't be too hard. Any idea, anyone? What is the solution here?
X is less than
能不能直接就是开根号，或者不是，就是把那个3移过去，然后呢两边都开个根号。
那你答案就是 x 小于3是吗？
要不要变号啊？就是这个符号。
你觉得呢？
我不知道啊。
很好，这个变号我们都得想一下，对吧？我们听听 Aaron 什么意见 ？Aaron?
We don't have to change the sign.
Okay, and then? So what
But
do you think this is the answer?
no, it has a different, like, x can also be equal to -3.
Can be equal to -3.
Yeah, but I don't know if it's greater than or less than -3.
Yeah, very good. So when we take a square root, just like Rika just mentioned, right? When you take a square root, you have +3, you have -3, but you don't know like which part to take, right? Lily, do you have any idea? Obviously, the key numbers are 3 and -3. So how do we know if it is greater than -3 or less than -3?
Has to be less than 3 and greater than -3.
Very nice. Has to be less than 3 and greater than -3. Very good. Why?
Casework, because if you plug in -4, it will turn into 16, and 16 plus 3 is 19, which is not greater than 12. So it must be greater than -3 and less than 3.
Yeah. Very nice. Okay, very good. So regularly, see if you guys can make sense of this. First, we can simplify this to be x squared less than 9, right? And it tells us that if we take a square root, you're gonna have 3 and -3. So the solution must be related to these two numbers. Okay, and just as Aaron said, I think the easiest way here is just to try out the numbers. First, it's very easy to figure out x has to be less than 3. That's very common. Like that's literally common sense, right? If x squared is less than 9, of course it's less than 3. 3, 2, 1, all that makes sense, right? They're less than 3. 3 doesn't work. I mean, 2 and 1 works, right? And then 0 works. And then for -3, you can always plug in and try. If you try -4, -4 squared is actually 16, correct? So x squared or -4 squared will be greater than 9 instead of less than 9. So -4 doesn't work. Then that means, what about the other side of it, -3, which is -2, right? If you plug in -2, that's 4. And that's going to be less than 9, right? So that works. And if you really think about this, between 3 and -3, you any number you can find, this square is gonna be less than 9, right? -2, -1, or -2.5, anything. Okay, so to trial numbers, I think that's a very easy method, and it works. Okay, so Rika, did it make sense? Any question at all? Yeah. Another way to think about this is that, yeah, okay, any question? No, okay, yeah. And then, yeah, you can always try casework and stuff, okay? So this is called quadratic inequality. And after we learn about quadratics, we will learn a systematic way, and it's actually a very easy way to do quadratic inequalities in any kind of form. Okay, we will learn a method that's very easy to tell, and that's gonna be like after we learn about quadratic functions. Okay, yeah. For now, you can just do casework, but there can be a very there can be very like a lot more complicated cases, but yeah, we will learn that. Okay. All right. Next. Maybe I don't want to do everything here. Let's say we do a word problem. Which number is bigger? This, I mean, okay. Maybe let's have a look. This just involves some trick. So, shouldn't be too hard. Does anyone have any idea?
The exponent is a factor of 46. So 43 to the power 46 can be 3 squared times 23.
Very good. So we can observe that 23, 46, they have a relationship, right? So we can change 3 to the power 46 into 3 squared to the power to the 23rd power, and becomes 9 to the 23rd. And how do we compare this with 9 to the 23rd?
Because so then 9 to the power of 23 would be the square root of 81 to the power of 23, and then therefore the square root of 82 to the power of 23 is greater than 3 to the power of 46.
Very nice. Yes. So once we found the same power, then that's the time to compare the base numbers, right, Rika, Lily? And when we compare the base numbers, that's basically just root 82 and 9, and 9 is root 81. So this has to be less than root 82 to the 23rd. So this will be a big number. Okay, any more question about this? Okay, very good, very good. And then next, word problems. Our goal is just to get the equation out, okay? And then to graph it, I can graph it for you, and we can solve for it, okay? So let's see what happens here. Maybe 1 minute, 2 minutes to read a problem. Just stop at question A, okay? We do one question at a time. So the restriction here, we have two things that will restrict my choice of playing video games or watching movies, right? The first restriction is the time, the amount of time I have. I only have 180 hours to do these, either games or movies, right? And if I watch a movie, it's gonna cost me 2 hours. If I play a game, then I can play the game for 20 hours. Okay, in other words, if you spend all the time playing games, you can play 9 different games. Or if you spend all the time playing watching movies, then you can watch 90 movies, right? Okay, Rika, did that make sense? And another thing, another opportunity cost. Yeah, yes, exactly. So yeah, exactly. Very nice, Rika. So another restriction is the money. So I only have $600. If I and each movie costs $10. So if I spend everything on movies, I can buy 60 movies. Or each game costs $40. That means if I spend all my pennies on games, then I can buy 15 games. Okay. So there were some restrictions. We need to translate them into equations. So before we even move on, let's translate those two sentences into equations, okay, into inequalities actually. So does anyone have any idea what should we suppose to be x and y? If you're not sure, you can read question 1.
Because that's the question.
Yeah, you said what? Suppose what?
Suppose movies to be X and games to be Y.
Yeah, movies to be X, games to be Y. Yes, suppose movies and games. Okay, so regularly, does that make sense? Because obviously the numbers of games and movies are restricted here. So right, so you want to suppose them to be X and Y. Or if you look at question A, if you read question A, it's actually asking for the numbers of movies and of course games that you can do to maximize your friends, right? So that means you want to suppose games and movies to be X and Y. Okay, so let's just suppose so Aaron, you said movies to be X, games to be Y. I'm just gonna go in order, okay? Games is X, movies is Y. Okay. For this, formally you should be writing a statement for it, right? So let's make it formal. Let's write it down. So let X be the number of games I can play, and Y be the number of movies. Okay. So how can we write an inequality for the first condition, 180 hours?
2x plus 20, no, 2y plus 20x is less than or equal to 180.
Very good. Okay, so Rika, did you see if you guys follow? So X is a number of games, right? So each game you're gonna play for 20 hours, so that's 20x. In other words, the maximum is 9, right? You can see that. And each movie lasts 2 hours. So if you watch Y movies, you're gonna spend 2 Y hours on it. And in total, it shouldn't exceed 180 hours. Okay, Rika, Lily, make sense? Everything good? What about the second inequality? Anyone? Everyone wanna try it? For money, you only have $600 in total.
So 10y plus 40x is less than or equal to 600.
Good. So 40x plus 10y less than or equal to 600. Very nice. Okay, so clearly that makes sense. 40x plus 10y. Okay. Again, just based on the cost of game and movies. So one is in terms of time, the other one is in terms of money. Okay. Any other inequality we can write down? There were, you could say, 2 inequalities that are implied.
Yeah, but also x has to be greater than 0, y has to be greater than 0.
Very
Greater
nice.
than, yeah.
Yes. So both x and y have to be greater than or equal to 0 because they're numbers of games and movies, right? So now we can plot these guys. Okay. So let's plot them just very roughly. Okay, very roughly here. The first one, that's 10x plus y less than or equal to 90, right? 10x plus y less than or equal to 90. You just take x and y intercepts. So y could be 90 at the best. X could be x could be 9. So say there 90 and here 9. I say 9 is here. This one, okay? It's gonna be less than this. You will see that 0, 0 fits. Okay, so it will be this part. And obviously it will be this part. If you go, the other part doesn't really make sense, right? Okay, for the second one, we just need to figure out the x and the y intercepts. So for y, that's going to be 60. Okay, so 60. And then for x, it's going to be 15, right? So with y0, x is going to be 15. So say here. The second inequality, if you plot it out, it's going to be, yeah, something like this, right? And again, you plug in 0, 0, it fits, right? So it'll be this part again. And again, the other part doesn't really make sense. You cannot have infinite number of games or movies, right? Doesn't really make sense. So now the intersection will be this part. And it seems to be an open region, but if you remember this, x and y both have to be greater than or equal to 0, then you will see that the closed region is just going to be this part. Okay, any questions so far? Plotting, graphing? That's just the basics, right? The fundamentals. I believe we are fine with this. So now we need to know the intersection, right? So for the intersection, we're just gonna make both of them make them equal to each other, right? So sorry, make them equal, and then we solve for linear system. Okay, so we solve for linear system here. That's gonna be, so I'm gonna write it down. For the intersection, we solve 20x plus 2y equals to 180. 40x plus 10y equals to 600. Solving by elimination makes sense, right? So the first equation, let's change it to just time by 2. 40x plus 4y equals to 360. And we do a subtraction. So equation 2, equation 1. I'm just trying to speed up, okay? So 2 minus 1, that gives us 6y equals to 600 minus 360, that's 240. So y is 40. And then plug it back in. X is gonna be, plugging it here, that's 400, that's 200, right? 200 divided by 40, X is going to be 5. Okay, for the intersection, you solve the system of linear equations, right? That should make sense. The solving is pretty easy, so I'm gonna do it quick. And then this intersection is going to be 540. Okay. And always remember for this kind of enclosed region, the intersection, like the endpoints, are the most important, right? So the endpoints here, another one is 0, 60. And the endpoints down will be this, which is 90. Okay. So for any further problems, we're just going to compare between these three endpoints. There's another one, 0, 0 here, but that doesn't do us any good, right? Obviously, you wouldn't want 0, 0. Okay, so recalculate, that makes sense. All right, then let's go back to question A. So question A says, if I make three friends each time I got a new video game and one new friend each time I watch a movie, then how do I maximize my number of new friends? So question A is asking for the maximum value of what? Three friends for a video game, one friend for a movie. How do we find an expression that can represent the number of new friends I can make this year?
Three 3x plus y is
3x plus
is
y. Yeah, exactly. Very nice. Okay. So recalculate, you guys are very silent today. So see if that makes sense. 3x plus y, right? Because again, x is a number of games. And then if you make 3 new friends whenever you play a new game, then that means you have 3x friends, right? X is a number of games. You play a game, you make 3 new friends. That's 3x friends. Okay. And for a movie, y is going to be the number of movies. And each time you watch a movie, you get one new friend. And that means you can make y friends from y movies. So that means the total number of friends you can get this year is going to be 3x plus y in question A. And you want to maximize it? Of course you want to maximize it, right? If you minimize anything, it's going to be 0, 0 in this question, right? So it will be maximizing. So you're going to find a maximum value of 3x plus y. Okay, Ricardo, that makes sense? How do we find it? 3x plus y. So question A, the maximum value of 3x plus y. Graph is here. We'll find out this. Anyone? Rika, Lily? How do we find the maximum value of 3x plus y here? Aaron?
use the region.
Use the
No,
region to be specific.
intersections of the region.
Exactly. Intersections or endpoints of the region, right? So first of all, this is not an open region. This is an enclosed region, right? So this maximum or minimum value, they must exist because it's enclosed. So that means the maximum or the minimum value, it must be at one of the endpoints here, one of the intersections here, okay? Ricky, that makes sense? One of the intersections here. There's one more intersection, which is 0, 0, but that obviously doesn't work, right? You just need to compare between the values when x is, x and y are these, or this, or this. Okay, Lily, Rika, that makes sense? So here it's better for us to make a chart, okay? Just make a chart. So let's say values of 3x plus y when they are at different points. Maybe not a chart, just maybe write them down. This equals to, okay, the first one is 0, 60, right? So 0, 60, that's the first endpoint. If you plug it in, that's going to be 60. Second endpoint is 540. So you plug in 540. Then this is going to be 15 plus 40, so 55. Okay.
So here we're trying to maximize 3x plus y, but all of the restrictions that were stated before in the question also apply.
Yeah.
Okay, so basically
because,
everything's restricted.
yeah, because the number of games, the number of movies are restricted by your time and your money, right? So that's why we try the 3 intersection points.
And also like 3x plus y is also restricted.
Yeah, 3 is I mean, because the whole region is enclosed, so the maximum or the minimum value of anything must exist. Because it's an enclosed region, right? No matter which way you move, you will always move out of the region if you move it sufficiently far. Okay, so there must be a maximum value and a minimum value for anything. Okay. Yeah, and lastly, we plug in the last intersection, that would be 90, and that means we have 27. Okay, so if you compare across the 3 endpoints, obviously the first one is the largest, and that means the first one is what we want. Okay, this is what we want. So that means 0 means the number of games, right? Y means the number of movies. So this means that if I get 0 game and 60 movies, that's the best for me, because that can bring me 60 friends, which is the most number of friends in this under this circumstance, right? Okay, X is game, Y is movie, so 0 and 6. Go back to the question. It's asking how many movies should I watch? So that means I should watch 60 movies for question A. 60 will be the answer. Okay, Rita, did that make sense, Aaron? Make sense? Yeah, Aaron, I think you're perfectly fine with this. So just regularly make sense. Make sure you guys understand it. Okay, if there's no problem, we can do B and C real quick. So B, let me copy it down here. Okay, now in B we have a different story. So if instead for games, I can make 5 new friends, and for movie, I can still only make 1. How many movies should I watch now? Game is X, movie is Y. So let's say Rika. I'm gonna make Rika and Lily do something, okay? So Rika, what is the expression here for the number of friends that I can make?
5x
嗯，
就是 number of friend 嘛。
对，X，然后呢？
加一
加一乘谁啊？
movie 是 y，
对，所以是加 y 没问题吧？
嗯，
加一乘 y
加一，
嘛，对吧？
对，加
因为
一个 y，
对，因为我是假设我玩 x 个游戏和 y 个电影，对吧？所以 x
嗯
个游戏我们乘5，就是5x 是我玩游戏得到的朋友。那一个 y 呢，就是我看电影得到的朋友，没问题吧？
嗯
Yeah, very good. And you're gonna find the maximum value. 那么瑞凯怎么做啊？怎么找到它的 maximum value 呢？
嗯，要算出
你猜着，
等于 something 吗？
对，就是要算出这个 maximum value 是几，并且当它取到 maximum value 的时候，x 跟 y 各自是几？怎么做啊？
就像之前那样0、60，
对，非常好，跟 A 问一样，直接把这3个
对，
intersection 再在你计算里面就完事了，对不对？
嗯
就这么做。OK，really make sense? Okay, all you need to do is to figure out the expression you need to find and then plug in all the intersections again. Okay, in this case, there's a difference. So I'll wipe this out, try it again. So 5x, 5x. The first one still gives you 60, right? Second one, that's 25 plus 40. That's going to be 65. Last one is going to be 45. Okay, so in this case, the second one is the greatest. That means you're gonna, so X is 5. So you should play 5 games and you should watch 40 movies at the same time. Okay, the question is asking for the number of movies. So 40 would be the answer. Okay, always go back to the question and understand what answer you should provide. Okay, because in most math competitions, it's either going to be multiple choice, or if it is like a long answer problem, you usually will have to circle out an answer at the end. Okay, so make sure you circle the answer, you provide a correct answer to the question so that you can gain full mark if you got it right. Okay, so make sense? Recap 没怎么样，还可以吧？没问题哈。So we'll leave the last one to Lily. 啊，Lily 又给你道星号题啊，难一点。Okay, you can read the question first. As many new friends as possible. Okay, you guys finished? What is it asking? It's asking that in order for it to make sense for me to buy only video games this year, what is the smallest number of new friends I should make with each video game? So he's asking, so let's go back to question A and B again. Recall that in question A, if I can make if I can make 3 friends for each game and only 1 friend for a movie, then that means I should choose the first situation, which means that I shouldn't play any game for this year to make most friends, right? In question B, notice that the number of friends with each game is increased. It increased from 3 to 5. So that basically makes video games more attractive to me, right? I want to play more video games because it brings me more friends. Okay, and indeed it does. You see, the optimal solution here will be. Oh my God, what happened? where's what? Okay, where's my equation? All right. Anyway, style. What? Okay, I'm not sure why it just suddenly disappeared. Let me put it back again. 5x at 65, right? Okay, so since in the second problem in the second in question B, for every video game I can make 5 new friends. So I want to play more games, and indeed we found that in the result we do play more games, right? You will see that since there were 3 intersections, question A is the first one, question B is the second one, and question C, sorry, not question C, like the third intersection. The third intersection means that you're gonna play 9 games and 0 movies, right? Watch 0 movies, but play 9 games. That's exactly question C. What question C is asking. Question says, when would it make sense for me to buy only video games this year? So it's actually asking, when is the third intersection, the third solution make sense for me? When does the third intersection provide me with the most number of friends, right? And when this happens, what is the smallest whole number of friends I make with each game? And again, for movie, it's still 1 friend per movie. Okay, so Lily, any idea? Or if you don't, since it's a challenge problem, Aaron, Rika, any idea? If not, I can give you some hints and then I can give it a try. Maybe I should make it clearer. So 5x plus y, 540 makes more sense, right? So what about 6x plus y, right? What about 7x plus y? To make video games the most like so attractive so that I should play all video games, right? I should spend all my money and time playing video games to make new friends. Then that means this like the number times x should be bigger, right? Because video games should bring me more friends in order for me to play it, right? To play it all. So maybe 8x plus y and on, okay? So the question is asking, which expression among all is the first expression that can give me like this answer to produce more the most friends, right?
Do you just try them out?
Yeah, but if you try them out, it's gonna take a long time, right? What if the correct answer is 18x plus y? Then you're gonna take a long time, right, Lily? So trying them out is viable. It just takes too much time. So we can
Suppose the code. Suppose like let the smallest number of friends be k, and then so kx plus y has to be the greatest, right?
Very nice. Okay, very good. So that's yeah, if that would be my hint if no one can say that. Very good. Okay, so Lily, instead of trying it, we can actually suppose the smallest whole number to be another, variable, another thing, right? Another, say, k, as Aaron said, and then make a chart for it. Does that make sense, Lily? This we don't have to try, right? We just know we're supposed to be k. Very good. So this one to be k, but again, let me write it down. So let k be the smallest whole number, be the smallest number here. Okay, let's just say here. Yeah. All right, then that means we're gonna work on kx plus y, right? So now the number of friends will be given by kx plus y. And again, we're gonna find the maximum value of it. And this maximum value should occur, okay, it occurs at 90. Very good. Then how do we determine the value of k? So Lily can think of it. How do we find the value of k? Going back to question A and B can give you a hint. Okay. Notice that if you're given 3x plus y or 5x plus y, what do you need to do? You just plug in the three intersections, right? So now you're given kx plus y, and you want to find the maximum value.
You plug
What
it
do you
in.
plug it in, right? Really makes sense? The same thing, right? Because k, you don't know. K could be 6, k could be 7, but it doesn't really matter what k is. No matter what k is, you're gonna do the same stuff, right? You're gonna plug in the three intersections. OK，瑞卡怎么样？目前还没问题吧？这道题你看设个 k 哈，设完 k 之后呢，我们要求这个 k 呢，我们就 plug in，跟前面一样，因为不管 k 是几3啊，还是5，还是更高，我们永远都 plug in 嘛，对不对？我们 plug in，let's see the values，OK？Let's see the values. So what is happening here? Oh God. Okay. Let me wipe it out. Okay. All right, so let's plug in. I'm gonna copy this down right here. Okay, so instead of 3x plus y, we're just gonna use kx plus y. So that means the result will contain some k, but that's okay. That means and because we know that the last one should be the solution here, so we can do some inequalities, right? So kx plus y, kx plus y, kx plus y. Okay, the first one always gives you 60. Okay, the second one is 540, so that's 5k plus 40. 5k plus 40, and the last one is just going to be 9k. Does that make sense to everyone? Right, we use kx plus y because that's the expression now, and we plug all three intersections in for it. Okay, and we're given that the last one is a solution, so the last one will produce the most number of friends for me. That's what it means, right? Okay, so what can we do now, Lily? How do we make the last one to be the solution? If the last one gives you the maximum value of kx plus y, what does that mean for us here? For these three numbers?
The number of friends.
Yeah, these are number of friends, remember? Kx plus y is the number of friends here, right? If the last situation, the last solution, 9, 0, gives us the most number of friends, what does it mean in terms of these numbers? What does it imply? Let's go back a little bit. Okay, think about question A and B, right? In question A, the reason why the first point is the answer is simply because 3x plus y is 60, which is the largest value among all in that situation, right? The largest values.
So the most amount of friends.
Yeah, so the most number of friends, right? In question C, it says the last intersection 9, 0 should give you the most number of friends, right?
Yeah.
The 9k being the most number of friends, what does it mean to us about something here?
They're all smaller than the last one.
Exactly. In other words, the last one is the largest number, right? Okay, so you see question A, the largest number. Question B, we choose the largest number because the largest number means the largest, like the most friends, most number of friends, right? So in question C, we're given that the last one is the solution, last one is the answer. That means 9k should be greater than either of those. Okay, did that make sense? And Rika, Aaron, that makes sense? It's the same as question A and B, right? Okay, good. So last thing here should be greater than either of them. So let's make and we can just write it down, right? So this tells us that 9k should be greater than 60, and also 9k should be greater than 5k plus 40. So we solve them both. The first one gives us k is greater than 60 divided by 9, that's 20 over 3. Second one, it gives us k is greater than 10. Right, 4k greater than 40, k is greater than 10. So combine them, 60 divided by 9, 20 divided by 3, yes. Okay, so combining them, what is the answer?
K is greater than 10. It's the,
yeah, because 20 over 3 is less than 10, right? And to do this, just as a review, guys remember, you draw a number line, right? 0, 20 over 3 is less than 10, so 20 over 3 is here, 10 is here. One is greater than that, the other one is greater than 10. Overlap region is 10, okay? So k is greater than 10. Does k equal to 10 work? When k equal to 10, that means these two are the same, right? So that means you can either take this or that. It seems like it also makes sense, okay? So maybe we should change it to equal to, you see? Even if all three are equal to one another, you can still choose the last one, right? Last one could be the answer. So it could be equal to, and that means the smallest value for k is 10. Okay, which means if you have 10x plus y, if you can get 10 friends from each new video game you're playing, then you should play, you should spend all your money and time playing video games to make most friends. Okay, Rika, Lily, that makes sense? Yeah, so Lily, you see, if you tried one by one, you try 6x plus y, 7x plus y, you're gonna try like 5 times to see it's gonna be 10, right? So it will be that it will still be viable though, right, Lily? Because no matter like 6 or 7 or 8 you try, you just need to do some very simple calculations and choose the largest number, right? Okay, so you will see that you know, once you try until 10, it will work. It doesn't take too much time because the calculations is very easy. Okay, so it's still viable, but this is the best. This is like we use k and solve for k. It's the most, you know, you could say most mathematical. Okay, so Rika, any question about the thing here? And then in the end, if you look at 10, this number, it should make perfect sense because think about this. Let's go back to the question again. Each movie 2 hours, right? So if a movie can give you 1 friend from 2 hours, then that means for 20 hours, equivalently, this game should give you 10 friends, right? In order just to balance out. Okay. Yeah, so that's why in the end we see 10, right? Because yeah, okay. So yeah, so it should make sense, I think. All right, so Rika, Lily, any other question? Okay, good. Let's take a rest. Maybe 5-6 minutes. Let's come back at maybe 5 minutes later. Okay, so 50, and then we will continue. We will just we'll go on to chapter 10. Okay. Okay, so I just decided we're gonna do one more question before we move on to chapter 10, and also for the remaining questions in chapter 9, I'm just gonna go over the ones that have a source on it. Okay, so there'll be these two, and then these two, and then this one. Okay, only these 5 more questions. Let's do one more because I think this one is it's a very typical one. Okay, I want you guys to understand how to do this kind of question. So very simple. We're given an inequality, and it's just asking how many different integer values. The integral is the adjective of integer. Okay, 整数的. All right. So he's asking how many integral values that b over a can take on. 就是说 b over a 呢可以取多少个不同的整数值。It's very straightforward. Just any idea. I'm gonna give you guys a hint first, okay? And see if anyone can think about it, and then we will talk about it, okay? The hint is just in the question, okay? So the question is asking for b over a, and this is nothing close to b over a, right? This is a over a plus b. So the first question is, how do you even transform from a over a plus b to b over a? That's a big problem, right? See if you guys have just any idea, any
Reciprocal.
a reciprocal, good, and then
But this would mean that you have to flip the sign.
yeah, okay, very nice. If you take a reciprocal and then how do you go from a plus b over a to b over a?
So that it would be 1 plus b over a.
Very nice. Very nice. Very nice. Very good. Okay, that's how you solve the problem. Very good. Okay. Lily and Rika, see if that makes sense. So first, notice that the question is asking b over a, and we have this, right? So we have to think about how do we go from a over a plus b to b over a? Now you will see that b should be on top, right? A plus b, it contains a b. It should be on the top. So we can first think of, why don't we take a reciprocal? Because that's an inequality. An inequality can take a reciprocal, remember? And we investigated how to take a reciprocal before. It will be just to, reverse the signs, right? Reverse the direction. Do you guys remember? Let's say 2 is less than 3, greater than 1. We will take a reciprocal. 1 is greater than 1 over 2 and it's greater 1 over 3. Okay, if they're all positive, then when you take a reciprocal, we reverse the whole thing, right? If they're all negative, you can also do this. But if there's some of them are positive, negative, then that's hard to say, okay? So let's just talk about, obviously here is all positive, okay? And after we take a reciprocal, we're gonna have, okay, I'm gonna wipe out a draft. So after we take a reciprocal, it's going to be a plus b over a. And again, how do we go from this to b over a? Then you will see that this fraction, if you just divide it, that's just going to be equal to 1 plus b over a, right? So to go to b over a, we're just going to minus 1. Make sense, Lily, Rika? Right? So the reason why I want to point out this question is simply because of this step. Okay, I want you, so Erin, you realize it, that's very nice. And Lily, Rika, I want you to, in the future, to always realize that once you have a fraction like this, you can always separate it. And also vice versa, okay? You will see that maybe another year later, okay, when we learn about very advanced algebra, MC10, MC12, we will see this coming. Okay, there were some questions that require you to add 1 to this so that you can go back to this. Okay, but for now, you just need to understand if you have some fractions like this, it can be written in this form. Okay, that's how you see the connection between this fraction and this fraction. Okay, this is pretty common in all sorts of math competitions, this kind of maneuver. Okay, so make sure you understand how to do it. 好吧，Lily Rika 没问题吧？这个地方主要就是想说啊 ，a 加 b over a 可以变成这个样子，然后把1减了就变成它样子。这个东西一定要会啊，因为这个经常出现在考试中，而且之后变难了之后，我们学到反正就是这本书不叫 Introduction to Algebra 嘛 ，right？ The next book is called Intermediate Algebra. That's mainly for MC12, but some part of it is for MC10. And then in that book, we will 我们就会看到有些问题啊，它就需要你把 b over a 这种情况加个1，把它变成这个样子来解题。但是我们也看到了啊，就是把这个东西搞清楚就行了，好吧？Okay, so that's it. Yeah, so just take a reciprocal and minus 1. That's all we need to do. Okay, so first we take a reciprocal, a plus b over a, and everything is a reciprocal over 5, and this is 2001 over 4, and the middle part just becomes, so important part, 1 plus b over a. So you're just gonna minus 1. You just have to subtract 1 from all sides. So that's b over a. Subtract 1, that's 199. So minus 5, 6 over 5. And this is 1997 over 4. Okay, so to find out the number of integer values, you just need to take find out these values, right? So the first one is 196, so 2000, so that's 5, so 499 and 1 over 4. Right? And this is 2000 divided by 5, so 400 and 399 and 1 over 5. Okay, so that means all the integer values we can take is from 499 till 399. No, 400, right? Because it has to be greater than 399 and 1 over 5. So 400. And that means we have 100 possible values. So you minus and plus 1, right? Minus plus 1. You have 100 possible values. And the integer between 400 and 499 would work. Okay, any question, Lyrica? First, taking a reciprocal, and then see the reciprocal as 1 plus our desired value, our desired expression, and then you minus 1. And that's it. Okay, Aaron, very good job. Lily, Rika, any question before we move on? No? Okay. Rika 没问题吧？看你晃晃的，没晕吧？OK， 好，那我们继续啊。Chapter 10. So chapter 10, Aaron, did you preview it or no?
No,
No, okay. Yeah, okay, just to understand. Rika, 你这个 chapter 10有做吗？我不是让你发给我啊，假设你做过了找不到也没关系，你做了吗？你记得吗？没有是吧？Okay, good. It's all right. So only Lily previewed. That's fine. Okay, so quadratic. Chapter is generally speaking very easy. So I'm gonna just sum up some main points here. I think you guys could understand. Okay. What 10.1 is trying to say is to solve quadratics in this form and also in a factored form. Okay, I will summarize for you. So if you have any so first of all, quadratic means that you have x squared, right? You have a square term, squared x. That's very easy to understand. Maybe let's talk about names first. So before everything, just some housekeeping, some basic terms. Okay. We say that okay, so if you have a polynomial, you guys know what a polynomial is, right? A polynomial looks like x to some power, x to some power. You can time by coefficient, doesn't matter, right? So if you have a polynomial, let's say we have x plus 1, or you could have x plus y, it doesn't matter, right? Since every term is only to the power of 1, every variable is only to the first power, then we say the degree of this polynomial is 1. Have you guys ever heard of the degree of a polynomial? Yeah, in math 10, right? Lily, Rika, that makes sense?
That was in math 9.
Math 9? Okay,
Yeah.
very good. Okay, so the degree of a polynomial, right? it refers to the highest power in a polynomial. Okay, so if you have something like this, if you have x squared plus 2x minus 3, then the highest one is x squared. So that means the degree is going to be 2. And usually we need to write down DEG, degree. 瑞可丽丽这个没问题吧？这个 degree 学过吧？在学校里啊，学到啊。Okay, good. Then if you have x cubed, then whatever, right? Then we say the degree is 3. If you have x to the power 4, then we say the degree is 4. Now, the degree doesn't only apply to x terms. It could have a combination of x and y as long as the sum of their powers is 3. So for example, for degree equals 3, you could also have, say, xy squared as a term. Okay, say xy squared plus 1. This is a third degree polynomial. Okay, because the first term here, you have nx and 2y, right? 1x, 2y, and combined you have 3 variables, multiplied together. Okay, a product of 3 variables, and that means you have a third degree polynomial. 好吧，这个 degree 就顺便说一下，因为我们其实并不会去学这种东西，因为这种东西比较复杂。Okay, this is very, very complicated. This is in calculus. Okay, 我们并不学啊，但是我们还是要知道，就是说，如果你遇到这种情况，假设 xy squared， 这个在你学校里会学，这个学校会告诉你说它是 third degree， 因为 degree 真正的算法是要算，就是算一个 term 的 degree 呢，就是看这个 term 啊，它里面到底有几个 variables 乘在一起。所以 xy squared 是个 third degree，OK，xyz 也是个 third degree，因为有3个 variables，OK，something like x squared yz this has a degree of 4，因为它们有4个 variables，OK，but we mainly focus on single variable, different degree polynomials, single variable, only x, no y, no z, okay, because that's going to be really hard. Not multivariable, okay, only one variable, x. And if you have x to the 5th, then it'll be degree of 5, and so on and so forth, right? And we do have some names for degrees from 1 to 5, okay? So for degree equals 1, we call it linear. Okay, so that's why we have linear equations, linear systems, linear functions. Okay, for degree equal being 2, we call it quadratic. Okay, for degree being 3, so does anyone remember from your math 9? It's called
Quintic?
quintic? It's called cubic.
Oh, cubic. Quintic is 5.
Quintic is 5, yes. Quintic. And degree being 4 is called quartic. Okay, quartic. Yeah, so those are the names. For the last 3, it shouldn't be hard because degree being 3, x cubed, right? X cubed, so we call it cubic. Okay, and for quartic, it's literally just the root word of quarter. You see, quarter means 4, right? Quart means 4. So this part means 4. So quartic just means degree being 4. And quintic, quint, is actually a root word for 5. It means 5. Okay, so this means 5. This means 4. Okay, and we don't have any more name for degree more than 5 because for degrees more than 5, we cannot find a generalized solution for it. Okay, but anyway, we will mention that later on. So yeah, Lily Rika 对这些名字熟悉吗？基本上最常用的前3个 ，OK, linear, quadratic, cubic. Okay, yeah. Now, so that's why sometimes in this kind of form, okay, we say that this is a quadratic term. Quadratic term. 中文就说是它是这个多项式的二次项 quadratic term， 对不对？因为这一个 term 它有2次嘛 quadratic term, okay? And we say this one plus 2x, the linear term. The linear term 就是中文就说是一次项，因为中文并不说 linear quadratic， 中文只说一次二次嘛，对不对 ？OK， 就是一次项、二次项。In English, we say quadratic term, linear term. And the last one we say is the constant term, right? 中文叫做常数项 the constant term, because it's a constant. 这个常数 right? OK, Lily 都没问题吧？ The reason why I'm mentioning all these names is that you will see them in questions after this chapter. Okay, so we say the constant term, which is simply just the constant, the linear term, the quadratic term, and if it's a cubic polynomial, we say this is a cubic term, the quartic term, the quintic term. But usually we just get to see linear, quadratic, and cubic. Okay, and then in each term we have a coefficient, right? So we say the quadratic coefficient is 1. The linear coefficient is 2. And the constant, we don't say constant coefficient, we just say constant, it's -3. 没问题吧？中文就说呢，常数项是-3，一次项系数 OK 吧？ Linear coefficient 一次项系数，中文就这么说，是2。And then 这个呢，我就是二次项系数是1。没问题吧？瑞卡就把这个英文熟悉一下 ，quadratic coefficient, linear coefficient， 好吧？管明白说啥？因为我上课也会用到这些 terms，OK？、包括 cubic coefficient and stuff，OK？And then in any sort of in any kind of polynomial here, the largest power or the largest degree, the term, and we call it the leading term. The leading term 就是说啊，在任何的不管你 degree 为多少啊，最高次项的那一项，我们就说是 leading term. Because usually we write the whole polynomial in a descending order, right? So for example, if you have a quintic polynomial, you should always put your quintic term in the very front, right? So you should have your, say, -4x to the power 5. This is the highest term. This is term with the highest power. It should be placed in the very front, right? 没问题吧？我们写多项式的时候，这个 power 是要 descending order， 是要逐渐下降的。所以比如说是 4x to the power 4 minus 3x cubed plus 2x squared minus 2x and then plus 1, something like this, right? 这个 power 是逐渐减少了 right? Okay, 所以这个第一个 term, so the first term is always called the leading term. This is called, you could say it's the quintic term, right? But usually we just say the leading term. And of course, the coefficient is called the leading coefficient. The leading coefficient, 好吧？看有没有疑问啊？中文呢就说是最高次项，这是非常 literal 的啊，最高次项系数，好吧？最高次项系数和最高次项。OK， 在英文呢说 leading term, leading coefficient， 在后面的题目里面呢，你就会看到题目里面就会说到什么 quadratic coefficient， 或者说到 leading coefficient， 或者说 leading term， 你就知道啥意思了。没问题吧 ？OK，just some housekeeping。看这些 terms 没问题，我们就继续啊。Okay, good. So to solve a quadratic equation, right? Chapter 10 is all about quadratics. So there were some different forms of quadratic equations. The first form, it looks something like this. So say x squared minus 16 equals 0. And this is very easy. We just get x squared equals to 16. We take a square root, right? Now, the only caveat, the only thing you need to remember when you take a square root is to add a plus minus sign, right? So plus and minus. And then the square root of 16, okay, which is plus or minus 4. Okay, don't ever forget about the plus or minus. Okay, so this is very simple, I believe, right? So for the first kind of quadratics, we could say it has a form of x squared minus c equals 0. Okay, Or you could have ax squared. You could have a number here, doesn't matter. You can always divide it over there, right? If you have anything like this, then you can just do x squared is equal to c over a, right? You just move the c over there divided by a, and you take a square root. So the answer would be plus or minus square root of c over a. Does that make sense? That's the first type. Very easy, okay? Okay, if it makes sense, the second type. The second type of quadratics will be, let's just get an example. Let's say we have x times x plus 2 equals 0, okay? For this kind of quadratics, always remember that this is a number times a number being 0, right? A number times a number being 0, it means that either the first number is 0 or the second number is 0. Does that make sense? Because if you think about it in another way, how do you get a product of 0? The only way to get a product of 0 is that one of the numbers is 0, right? 0 times a number is 0. And you know, on the other hand, if both numbers are not 0, can you get a 0? It's not possible, right? Good. Okay, so Rika, that makes sense. If both numbers are non-zero numbers, then you couldn't get a 0，没问题吧？你一个数乘以一个数等于0，说明其中一个数必须为0。两个数都不为0的话，你乘怎么会等于0呢？对不对？因为只有乘以0才等于0嘛。Okay? So when you have this kind of form, very easy. Either the first one or the second one, okay? So either x is 0 or x plus 2 is 0. So that means you have x equals to 0 and negative 2. Any question? Okay, Lily, 你觉得这个 make sense 吗 ？Number 2这种 type. Okay, because I see that in your homework, this is the part you got wrong. Okay, every time when you have this question in your homework, you miss the first solution. You only gave me the second solution. Okay, 这里你看有没有问题啊？一定要注意 x equals 0 is also a solution here. Okay, in your homework, you only give me the second solution. Okay, so make sure I understand this, and we'll carry on. Okay, 瑞凯没问题对吧？非常简单啊，就注意 x 等于0也是一个解，好吧 ？Okay, and number 3. Oh, by the way, so number 2 usually doesn't appear like this because usually doesn't really give you brackets, right? Usually it will multiply out, so it will actually be x squared plus 2x equals 0. So that means if you have this, you should first factor it out, right? Find a common factor and factor it out, and then it will be this. Okay, so the summary of the second type would be if you have anything like ax squared plus bx, a and b are just some coefficients, right? Equals 0. This kind of equation, it should first factor out x. X times ax plus b equals 0. Then you would have either x equals 0 or ax plus b is 0, which means that x is going to be negative b over a. Okay, make sense? Any number x squared plus some number x, you factor out x and you just have this, either this or that. Okay, so Lily Reka, any question about this? Okay, good. Number 3. So number 3 is just very similar form to number 2, okay? In number 2, you only have one bracket and an x, right? So in the third form, you could have 2 brackets. So for example, if you have x minus 2, x plus 4 equals 0. And again, 2 numbers have a product of 0, right? So either the first number or the second number is 0. So either x minus 2 is 0 or x plus 4 is 0. Two solutions, right? So that means x is either 2 or negative 4. Okay, so a factored form is very easy to be solved, okay? Very easy. But again, usually it will be in a form of multiplied out, that kind of form, right? So in this case, it would be x squared plus 2x minus 8 equals 0. So this tells us that if you have this equation, x squared plus 2x minus 8, you should factor it out, and then, well, it's just going to be either factor equals to 0. Okay? And to factor this kind of quadratics, well, from what I understand, all three of you are very familiar with it, right? Okay, just to make sure, does any one of you need me to talk about how to factorize, how to factor these kind of
I don't know how to factor by grouping.
You don't know how to factor by grouping. Do you know any method to factor it?
Yes.
Yeah, then that'll be okay. Okay, you don't have to do factoring by grouping.
Okay, okay.
Yeah, actually, factoring by grouping is the worst method here. Yeah, it's literally the worst. So don't do it. Yeah. So usually we should
factor by grouping when the coefficient of the quadratic term, like x squared, has like it's greater than 1.
Okay, even if it's greater than 1, okay, we usually use the easiest way. So everyone, I'm not sure if you are familiar with it. It looks like, something like this, 1 1 this. Have you ever seen this kind of method before?
No.
No? Okay. Okay, just to make sure, Lily, Rika, do you guys use this kind of method? Rika,
这个我当然学过了。
这个你刚学过是吧？就是哪怕 leading coefficient 不是1，是个，比如说是个3，那也是这样，比如说一个1，一个3，对吧
哦，对对对，学过的之前。
？OK， 学过了是吧？OK，Lily，你学过吗？你学过这个方法吗？没有吗？比如说这个
能
没有学过是吧？OK，then let's talk
有
about
可
this
能学
method。
过。
那我们说一下，好吧？因为这个方法是最快的，也是最好的，也是所有就是 all math competition students they use this method. This is usually referred to as the Chinese way. OK，这个中国的方法，因为 because most high school teacher here they don't even they're not even aware of this method. Yeah. Lily，你说啥？
我一般就比如说就这个 equation，我一般能看出来，like
对，看出来，但是比较复杂的，比如说数字大了就不好看出来，对吧？
我好像一般是把 x 它的什么 coefficient 和那个最后一个数字 multiply，然后就在那找。
对对对对，刚刚那个方法其实就是这个方法。刚刚这个方法就是前面两个相乘是 leading coefficient，后面两个相乘是它的 constant term，and then cross multiply and add，get a middle term. It's okay, I'll explain. Okay, yeah. 那我们就讲一下这个方法。那么估计今天主要讲这个 factoring 了。OK，这个方法 so this method was not mentioned in the textbook, so you wouldn't see it in textbook, but it's very easy and it's very quick. Okay, let's do this first. So let's say, okay, let's use this example. Let's just use this as an example then. So I'm going to put it here. Okay, so let's first think, if it is factorable, then it will become something like this. So become x, well, plus or minus a number, you don't know, right? And another x plus or minus number, right? First of all, you know that you only have 2x and, you don't have any, the coefficient must both be 1 instead of 2 or 3 because the leading coefficient is 1, right? Okay. So we know that the first x term, the first linear term times the second linear term, it should produce the quadratic term here. And since the coefficient is 1, so both have to be 1. Okay, we start with leading coefficient being 1. because that's the easiest form, right? Now the problem is, what are the numbers here, right? You could put a positive number, you could put a negative number, right? Now we would see that the two constant numbers, the two numbers we put in both brackets, they should have a product of -8, right? Because when you open up, let's see. So if you have x plus a, x plus b, let's just say, suppose those are numbers are a and b, you're gonna get x squared, you're gonna get bx, you're gonna get ax, so you're gonna get a plus bx, right? And eventually you're gonna get a times b. So the two numbers, they will have a product of this -8, right? So that means if we go back, this number and this number, they should have a product of -8. That means you could do, say, -1 and +8. You could do -2 plus 4. You could do -4 plus 2, or you could do -8 plus 1. That's basically all the possible choices here. Okay, make sense? I think by far it should be the same as whatever Lily or Aaron you guys learned, right? Same, right? Okay. Now we have to choose between them, okay? But which one is our solution? Now we have to look at the middle number. It's +2. So think about this. The next part will be x times this number and this number times x. So say that you choose the first group, then you will have -1x and then plus 8x. So that means you're gonna have 8 minus 1, you should have a 7 in the middle, right? So if you have a 7 in the middle, that will be the first one. It will be x minus 1, x plus 8. And so on and so forth, right? You can try different ones. If you try the second group, that's gonna be -2x and then plus 4x, right? And that means the middle part should be a +2, and there we go. X minus 2x plus 4, that's the correct answer. Okay, now let's have a look. How do we simplify this whole process? How do we simplify this whole process? Now, you could do this. So say that I'm gonna put, I'm gonna just wipe this out. I'm gonna go back to say that we have x plus a, x plus b, okay? That method works like this. 那个 Rika， 我不知道你学的这个方法搞明白这个方法的原理没有啊？原理很简单，对吧？我们稍微可以讲一下。So you can put x plus a here. You move the second factor down, okay? So you would have this. You would have 2 terms here and 2 terms here, okay? And then let's wipe out these brackets. Okay, so basically what do we have here are just 2 terms. Okay, so 2 factors. One is x plus a number, the other one is x plus another number. And now, to further simplify this process, we can leave out x because we know that both of them should be x, right? So for the first term, we can actually just wipe them out and just put a coefficient here. So this one and this one, they actually mean 1x and 1x. They are the linear coefficient here. Okay, they are the coefficient for the x term. But they are both 1 because the leading coefficient here is 1. Only 1 times 1 gives you 1, right? Okay. And now, for these two numbers, we just wipe it out and we try. What do we try? We try 2 numbers that have a product of -8, remember? Because these numbers, a and b, they should multiply to be -8. So we just try different numbers. We can try -1 and 8. We could try -2 and 4. We could try -4 and 2 and stuff, right? Or -8 and 1. Notice that, say that you tried this one. This actually just means x and x. So this means that x minus 1 is your first factor and x plus 8 is your second factor. Okay, make sense? If you try the second group, it simply means that x minus 2 is your first factor and x plus 4, because this is a positive number, right? So x plus 4 is your second factor, and so on and so on. It just means you have the first factor on top, second factor on the bottom. Okay, now here comes the important part. Okay. So among all the choices, which one is the correct one? We just need to do this. We cross multiply and then add them up. Okay. Let me move this away. So we cross multiply and add. So we do 1 times 8, that's 8. And then we add 1 times -1 this way, okay? 1 times -1 minus 1, that's going to be 7. What this means is actually, remember, these are actually x terms, right? What this means is actually just x minus 1 times x plus 8. If we time them out, we have x times x squared. We have minus 1 times 8 minus 8, right? So x times x is x squared. -1 times 8 is -8, okay? And then what do? We do this, see? Cross multiply and add, right? We cross multiply, we have 8x. And then x times -1, we have minus x, right? You see the middle part? The middle part is produced by adding the cross products here. X times 8, that's 8x. And x times -1, that's -x. That's why you have a 7x here. And the 7x is represented by this 7, you see? Because the reason why you can get this 7 is to get cross products and then add them up. And the linear term is produced by cross products and addition. Make sense? So what it actually means is that you see x times 8, that gives you 8x. And x times -1, that gives you -1x. And that's why you can get 7x. Okay, so that means if you have 7x there, that would be the answer. Okay, but it doesn't. So yeah, that's just what it means, okay? And that means you can try the second group of numbers. You try 1 and 1 here. Again, you cross multiply and add, okay? Cross multiply and add. So 1 times 4 is 4. 1 times -2 is -2. You get 2. And now we'll see that this 2 matches. See, this 2 matches with the linear term here, right? And that means this is the correct answer. This one is the correct answer because it gives you the 2, okay? So there's no need to try furthermore, and this will be the answer. And to be specific, the answer will be this is x, this is x, right? So this is the first factor, that's the second factor, remember? So that's x minus 2, x plus 4. And again, if you time it out, if you align them in this way, you will see it, right? So it will be x squared, and in the end you have -8. Cross multiply, right? X times 4, 4x. X times -2, minus 2x. This part is the reason why you see you have 4 minus 2 equals 2. This 4 minus 2 simply means 4x minus 2x equals 2x. This is the part you generate the linear term, the middle term. And that's this whole method, okay? To summarize, you want to find two numbers that multiplied to be the first leading coefficient. Okay, these two numbers should time to be the first one, okay? The second two numbers should have a product of the constant term. And then you cross multiply and add, it should produce the middle term, the linear coefficient. Then you know what two factors you have. Okay, so let me demonstrate with another example. So this method, as you practice, it becomes faster and faster, okay? So let's say we have x squared minus 7x and then plus, let me see. Let's say we have minus 44, okay? Okay, again. So the first two numbers should have a product of this, right? That's 1. So that means we just have 1 and 1. The last two numbers, these two numbers, they should have a product of -44, right? So you can try some different numbers. Now, negative 44, you can try negative 11 and 4. You can try negative 22 and 4, and 2, and whatever, right? But recall that once you determine these two numbers and you cross multiply and add, you should get this middle number, negative 7, right? So this tells you, of course, this doesn't work. Because when you do this, this is negative 43. And even without any calculation, you should know it doesn't work because one is negative 44, the other one is only 1. It's far away from negative 7, right? You wouldn't even try this, actually, right? To see that you get a negative 7, I think negative 11 and 4, right? That should work. Okay, and that gives you what? That gives you 1 times 4 is 4, 1 times 11 is minus 11, and that indeed gives you negative 7. And that matches with the middle coefficient, right? So that means your answer should be, you put x back, you put the brackets back if you want. And once you're familiar, don't have to do this. And that means you have x minus 11 times x plus 4 equals 0.
So basically, two numbers multiplying to negative 44 and two numbers adding up to negative 7.
Yeah, when you do cross multiply, okay, this number times this number times this, that's negative 7. Yeah. In this case, since the two leading numbers are just 1, you could say that the sum of these is just the middle term, right? The sum is the middle term, the product is the last term. But that's simply because the first coefficient is 1, okay? If it's not 1, then that's not true. Okay, I'm gonna give you one more example with a coefficient that's not 1, okay? That's not 1. So maybe let's pick an example from the book. When the leading coefficient is not 1. Okay, here, a bunch of them. Let's choose, let's say this, just to question A. Okay, so again, the first two numbers should time to be 10, right? Because that literally means that some x times some x is 10x. It's 10x squared. So you could just do 2 and 5. I mean, you could do 2 and 5, or you can do 1 and 10. So that means you have to try, right? So let's try 2 and 5 first, okay? So 2 and 5, it actually means 2x and 5x. So that's why you have 10x squared, okay? The last two terms should time to be 1. That means you can have 1 and 1 or negative 1, right? So if you think about it, if you have 1 and 1, then of course the middle term is positive because you have positive number plus a positive number, right? So because of the fact that the middle term is a negative number, you should try minus 1. And this will give you minus 7, right? So in this case, you just write down minus 7 here. It doesn't match. That means we try the other way. That's going to be 1 and then 10 and minus 1 and minus 1. See, this way it gives you minus 11. So this is a correct one. And that means this becomes, you put x back, right? The first term is x minus 1. Second term is 10x minus 1. There we go. You see, it's very fast. And it's very easy. Okay, Lily, Aaron, does that make sense?
Yes.
Yeah, okay. Lily, 你不是这么做的吗？你就直接看出来了。So Lily, I don't know. Yeah.
我就是1乘10，然后10大概什么-1，然后-10。
反正我是看你这边做的很好啊，你对都做对了，但我不知道你花多长时间。就这种东西应该是很快就能做出来。如果你花了很长时间，就不太对劲儿。如果你很快就做出来了，那不管你用什么方法都是好方法，好吧？你就接着用就行了。OK， 好吧？Yeah. Maybe one more example, and we'll call it for today. Okay, let's call it an end. So one more example. Let's say this. See, big numbers. Okay. Now again, first two numbers should time to be 18. So that means you have you have a bunch of choices. Let's have a look. Okay. Notice the last number. The last number is 5. So that's very easy. Only 1 and 5, right? And they shouldn't be negative because the middle number is positive, right? So you can easily write down 1 and 5. And to test out the first two numbers, don't do it blindly, okay? Do it wisely. So say that you want to try 3 and 6, right? 3 times 6 is 18. If you do 3 and 6 here, what happens? 15 plus 6. That's the one. That's 21, right? There we go. Done. So here you have 15 plus 6, that's 21. That's the one. So you put x here, you put x here. This is actually plus, right? Positive. Okay, so that means this equals to 3x plus 1, 6x plus 5. Okay, there we go. So in other words, if this equals to 0, which is a quadratic equation, and that means either the first factor equals to 0 or the second factor equals to 0, which means x is either -1/3 or -5/6. Okay, Aaron, did that make sense? Yeah. So yeah, how do you feel about it, Aaron? It's I believe should be faster, right? Than factoring by grouping.
Yeah, it's faster.
Yeah, and factoring by grouping is a lot harder. Yeah. So this is yeah, we could say the best method, fastest method. Yeah. All right. So we basically completed from 10.1 to 10.3. Okay, so from 10.4 and on, you could so Lily could preview it, and then for Reka and Aaron, at least you have to finish from 10.1 to 10.3 exercises for this week. Okay, and if you have time, you can preview 10.4.